All right, so let me finish up 7.1 for you. I'm on my school device, so this is brand new to me, so please bear with me. All right, so these were included if you printed the notes that I posted in Teams. Coterminal angles, two angles that have the same terminal ray. Okay, what does this mean? We're going to spend a whole lot of time studying angles, and angle measures are not unique. Which means if I take one rotation around the circle, I've gone 360 degrees. I end there. If I take another rotation, I've now gone 720 degrees, but I'm back at the exact same spot.
What are you doing today?
I'm making a video. So what two angles that have the same terminal ray means two angles that end at the same spot. Maggie's trying to help me here. So what do I have to do? If I'm at 135 degrees, if this is where I start, oopsie, bear with me, 135 degrees would land me about there. Then how do I get right back to that spot? Well, I have to take one full rotation. So to find coterminal angles, you're literally just adding 360, and then you're taking that angle measure and you're going to subtract 360 degrees because they're going in the same. I can rotate in a clockwise or a counterclockwise direction and still end up in that exact same, at that exact same terminal ray that I started. Okay, so this would be 495 degrees. One would be at negative 225 degrees. Okay, so I can start with a positive or a negative angle measure, and I'm still just adding 360, that would get me to 320 degrees, and then I would take negative 40 and subtract 360 degrees. So wherever I start from, I'm just going one rotation clockwise, one rotation counterclockwise. Okay, so if my angle measure is measured in radians, remember that 360 degrees is 2 pi radians. So I'm going to take my angle measure and I'm going to add 2 pi to it. How do I add fractions? I have to make sure that I have a common denominator. My common denominator would be 6, so multiplying top and bottom by 6 would give me 12 pi over 6, and that verifies 12 divided by 6 is 2. So 13 pi over 6 would be one coterminal angle. And then I would take pi over 6 and subtract what I have with the common denominator already. So negative 11 pi over 6. Okay, so 3 pi over 4, I'm going to use my common denominator right now. Common denominator of 4 would make 2 pi equal to 8 pi over 4. When I add those together, I get 5 pi over 4. If I take negative 3 pi over 4 and subtract 2 pi, it gives me negative 11 pi over 4. All right. Next and last. Oh, wait. Now I think I'm going to go this way. All right. Angle measures. Now, this chart is going to haunt you for the rest of this chapter. We're going to come back to it often. If I start, I'm just going to start with my angle measures. So 0 degrees. Okay, this is where we always start on the positive x-axis when we rotate angles. I'm only doing these angle measures because these are the angle measures that I know the trig values of, which is coming next. Nope. So the first one I would rotate to 30 degrees, 45 degrees, 60 degrees, and then up at the positive y-axis would be 90 degrees. Okay, now let's think symmetry. So all my quadrants are symmetrical. So if I go from here, another 90-degree rotation would put me at 180. Down here would be 270, and then a full rotation is back at 360 degrees. Okay, so if everything's based off the x-axis, so I'm going to take 180 degrees. If this first angle is 30 degrees away from 0, this first angle over here has to be 30 degrees away from 180. So that gives me 150 at this angle measure, 135 here, and then 120 there. Using the same line of reasoning, now I'm a 30-degree rotation bigger than 180. So that would give me 210, 225, and then 240 degrees. So now I'm going to be 30 degrees before 360, because that's my full rotation. So this would be 330 degrees, 315 degrees in the middle, and then 300 degrees closest to the y-axis. So, like I said, we'll be doing a lot of these, but my challenge to you, and I'm not going to give you the answer just yet, find all the radian measures for the degree measures I just put on the circle. So, find radian measures. And again, I'm sorry for the seemingly amateur print. All right, that'll do it for this.